Greetings, detectives. Mrs. McKay here, and we are working on Clue 7-2, vertical translations. Let's start by writing our learning target. I can complete a vertical translation of a linear function. And as I mentioned in the previous video, Case 7 is all about shifting our thinking. We're used to thinking about math in a certain way. We've learned certain types of equations. We've learned how to do math a certain way. And now we're going to see how it's connected to other math that we've learned. So in Case 6, we did some work with connecting geometry and algebra. We're going to continue to do some of that in Case 7. All right, so let's start, first of all, by reviewing a little bit of some of the terms and math concepts that we've already studied. First of all, slope-intercept form. Slope-intercept form is an equation that represents a line, and it's often written like this: y equals mx plus b. It's not the only way that we write a line, but we use it a lot. It's kind of like a person's first name, okay? We call people by their first name all of the time. Y equals mx plus b. The m has an important representation, and the b has an important representation. What does the m represent? That's right, it represents the slope. And the b represents the y-intercept. Good. The x and the y are simply the coordinates of each point on the line, which means when x is 1, y is something. And we can plot it on a coordinate plane. All right? But there's another way that we can represent this slope-intercept form, and that's using function notation. And function notation always says that our equation is a function of x. So we write f of x, which means function of x. F of x equals mx plus b. And all that means is that instead of having a y here, we say that every time we plug something in for x, we get a y, but it's also the f of x. It's the function, it's the output, it's what we get when we put 1 in for x. So if I said f of x is equal to 3 halves x, let's just do 3. We won't do the halves. 3x plus 1, 3x plus 1, I could create a little t-chart that would have an x here and an f of x here, which also means the y value, okay? And I could actually plot these points. When x is 0, y, or f of x is, so when I say f of 0, I put 0 in for x, and I get 3 times 0 is 3, plus 1 is 4. So y is 4, f of x is 4. When x is 1, f of 1, I put 1 in for the x, and 3 times 1 is 3, plus 1. 3 times, oh, this one's not right, is it? That's a 1. So 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3, plus 1 is 4, okay? And then when f of 2, 3 times 2 is 6, plus 1 is 7. And I could actually plot those points, couldn't I? And I could label that line f of x. So that's the other reason why we use function notation, is because then we can label different lines. I can have an f of x. I can also have a g of x. And g of x is a completely different line, and that's the way that I can tell the difference between them. And the last thing that we just got done talking about in case 6 was translations. So let's say that I have this shape. And I want to translate this shape or this graph, and I want to translate it down 2, okay? Then all I would do is I would take each point of that shape and move it down 2. I'm not going to be very good at this, but you can see that in essence, oops, I didn't do it very well. It's going to look something like that, isn't it? Where everything shifts down 2, right? So translations, we already understand, and I'm not translating it horizontally. I'm just shifting it up and down the y axis. So I'm only paying attention to the y values, all right? So I'm basically doing y minus 2, but x is x plus 0 because I didn't shift it this way, all right? Now, let's take those 3 ideas, slope, intercept, function notation, and translations, and work on putting them all together in a simple equation over here. Here I have an equation, f of x equals 2x minus 4. F of x equals 2x minus 4. And I want to graph this equation. So I'm going to go ahead and graph f of x equals 2x minus 4. So if I wanted to graph it, I would first look at my b, or my y-intercept, which is right here, negative 4. And I'm going to graph negative 4 on the y-axis. 1, 2, 3, 4. Then I'm going to take a look at my slope, which happens to be 2 over 1, and I'm going to go rise over run up 2 over 1, up 2 over 1, up 2 over 1, and then I'm going to connect my points and make a line. And I'm going to label that line f of x because that's the name of this line. It's f of x. F of x equals 2x minus 4. So this is f of x. And now I'm going to translate my line f of x, and I'm going to teach you a new, it's not really new because we're doing it with points, the translation form. And I'm going to create a new line that's called g of x. And g of x is just f of x plus 3. So I'm going to translate f of x 3 up. I'm going to move it up 3. So that means I'm going to take each of my points that I created on my line of f of x, and I'm going to translate them. I'm going to translate them a positive 3, up 3, y plus 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. I'm going to make another one down here. And you can see that I just translated each of my points. And one of the things that we know about translations is that every point on the image is the same distance away from every point on the pre-image. So that means the corresponding points of the pre-image. So that means that f of x and g of x, when I measure this distance between this point and this point and this point and this point, they're all going to be the same. It's the exact same difference. So these two lines are what? They're parallel. That's right. So this equation, g of x, which I'll label right here, this line, g of x, this function, is just f of x with adding 3 to it, plus 3. And that's the translation form, okay? So we're writing g of x in terms of f of x. G of x is f of x plus 3. And all I've done is I've moved it 1, 2, 3 up the y-axis. Now, if I wanted to write g of x in slope-intercept form, I could do that. I could look at my graph and I could say, well, my y-intercept is -1 and my slope is up to over 1. So my slope is 2x and my y-intercept is -1. So g of x is equal to 2x minus 1. And I've just written it in slope-intercept form. Now, I happen to use my graph to do that, but could I have figured out what g of x was in slope-intercept form without graphing it by just looking at my translation form? Well, what happened? What changed between f of x, which was -4, and g of x, which is -1? Because that's the only thing that's different between f of x and g of x is the y-intercept. So what happened between here and here? What did I do? I added 3. So if I know what f of x is 2x minus 4, and I add 3 to it, combining my like terms, I should get 2x minus 1, which is what g of x is. So I didn't even have to graph it, but I hope you can see how graphing it, when we graph it, we can see that we've actually added 3 to our y-intercept. Let's go down to this one. On this graph, I now have two lines, f of x and g of x, and they have already been graphed for me. And I've actually even been told what the equation of f of x is. F of x is 1/4 x minus 3. 1/4 x minus 3. So let's look at it. It's that should be right there, but we go down 1, 2, 3, and that's where we're starting at -3, and our slope should be up 1 over 1, 2, 3, 4, and it is up 1 over 4. So here's my line, f of x equals 1/4 x minus 3. And now I want to look at g of x, and I want to figure out what the translation form of g of x is, meaning what is g of x in relationship to f of x, because it looks to me like g of x is a translation of f of x. Do you see that? Do you see that we've just shifted? We've just slid f of x up. If f of x is our pre-image, g of x is our image. So what did we do? We took f of x and we moved f of x. If I look at my y-intercept, I went up 1, 2, 3, 4. So g of x is just f of x plus 4. F of x plus 4. And if I wanted to write g of x not in translation form, but in slope-intercept form, I could look at my g of x, and I could graph it because it's graphed. I could figure out what the equation is, and that is g of x crosses the y-axis at 1, and its slope is up 1 over 4. So it's 1/4 x plus 1. Now, could I have figured this out without looking at the graph? I certainly could. I had to look at the graph to be able to figure out what the translation was. But once I knew what the translation was, then all I really had to do was just add 4 to f of x, because here's f of x, 1/4 x minus 3. I add 4 to it. Negative 3 plus 4 is 1. My slope stays the same, 1/4 x plus 1. See that? All right. The next one. Here I have a table. I have a table of x, a value of x, and what f of x is for each of those values. When x is 3, f of x is 11. When x is 10, f of x is 46. When x is 25, f of x is 121. When x is 40, f of x is 196. Now, I don't know what the equation of f of x is, but that's all right, because I know what g of x is when x is 3. When x is 3, g of x is 26. When x is 10, g of x is 61. When x is 25, g of x is 136, and so on. And all I want to know is, what is g of x in its translation form? So I'm telling you that g of x is a translation of f of x. And the question is, how much is the translation? So think about it. What is g of x in relation to f of x? What did I have to do to f of x to get to g of x? Well, when x is 3, f of x is 11, and when x is 3, it translates to g of x and it becomes 26. So what do I need to do here? I need to add something to f of x to get g of x. So g of x is f of x plus something. What is it? Well, the way that you could have figured that out was you could have thought about what's the difference between 11 and 26. I had to add 15. And I have to make sure that it's consistent. Do I add 15 to 46 to get 61? I sure do. Do I add 15 to 121 to get 136? Yes, I do. If I add 15 to 196, do I get 211? I sure do. So f of x, whatever f of x is, I don't know, I could try and plot these points on a graph, but it'd have to be a pretty large graph to get to 196. That's too much work. I don't want to do that. All I have to do is see that f of x is a translation of g of x because I'm adding 15. So whatever f of x is, when I add 15, I get g of x, and that's the translation form. All right? Now, let's have you do a little bit of practice. Here I have two problems. I have f of x equals 0.5x, and I have g of x equals f of x minus 3. And I want you to tell me what g of x is in translation form. I'm sorry, not in translation form, because this is the translation form right here. I have f of x equals 0.5x, and I've translated it. G of x is f of x minus 3, meaning I've translated it down 3, okay? So can you tell me what g of x is in slope-intercept form? Tell me what it is in slope-intercept form. Now, you may want to graph it if you think it will help you to see it, and that's perfectly fine. Or you might be able to just figure out what g of x is because you know that g of x is whatever f of x is minus 3. So go ahead and tell me what it is. Now, if you wrote 0.5x minus 3, g of x is 0.5x minus 3, then you've got a good idea of how to translate vertical equations. But if you struggled with this, let's go ahead and graph it. The first thing we have to do is we have to graph f of x, and f of x equals 0.5x. Now 0.5 is hard to think of in terms of the slope, so I'm going to change that to 1/2 because 0.5 is the same as 1/2. But I don't have a y-intercept. Where's my y-intercept? I need to be able to put my y-intercept here. What is my y-intercept? It's 0, isn't it? So that means that I'm going to start right here, and I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. So I'm going to go ahead and say this is 1, 2, 3, and 1, 2, and I'm going to go up 1 over 2, up 1 over 2. And there's my line right there, okay? And f and g of x is just f of x, which is this line, translated down 3. So that means that g of x, let me change my color, is going to start down here. My y-intercept is going to be at -3, but I'm still going to go up 1 over 2, up 1 over 2. Connect my lines, and you can see that I have my two parallel lines, and I can now write what the equation of g of x is in slope-intercept form. It's -3, and it's 1/2 x minus 3, or 0.5x minus 3. So if you needed to graph it, that's okay, but I hope that you see that really all I had to do is take whatever f of x was, which was this right here, 0.5x, and subtract 3. And then I got g of x. All right, one more. This time I'm not going to give you a graph to work out, and I'm using really big numbers. So see if you can tell me, if I'm telling you that f of x is 22x minus 12, and that's slope-intercept form, and g of x in slope-intercept form is 22x plus 213. Can you tell me, how did I translate f of x to g of x? Give me the translation form. Give me what g of x is in terms of f of x. Well, if you were thinking about this, you would have thought that on the y-axis, I started at -12, which could be down here. We'll say this is -12. This is where I cross the y-axis. And g of x, I cross the y-axis way up here at 213. So how did I get from -12 to 213? How did I get from -12 to 213? Well, I went up to 0, which would be 12, and then I went an additional 213. So I actually went -12 plus 213, and that would have given me 225. So g of x is f of x plus 225. That's the translation form. F of x plus 225, because I basically had to figure out how did I get from -12 to 213. I had to add 225. All right? That's all that we have for this lesson today. So go ahead and write a key idea. I think if you're smart, you'll make your key idea related to the y-intercept, that when you're translating, when you're writing translations, you're translating linear equations, the only thing that happens is that your y-intercept changes. It goes up or down, right? Everything else stays the same with parallel lines. And after you've written your key idea, you'll be done, and I'll see you in class.